Hello, everyone. Welcome to Vinray's Academy. This is Vinay. Welcome to the final video in our specialized testing series. Today, we're diving into the fascinating world of AR, augmented reality, and VR, virtual reality testing. With AR and VR applications transforming industries like gaming, healthcare, education, and retail, ensuring a seamless and immersive experience is crucial. In this video, we'll cover the challenges of testing AR VR apps, the tools available, and the best practices for delivering high quality immersive experiences. Let's get started. Let's begin by understanding AR and VR. Augmented reality, AR, enhances real world environments by overlaying digital elements such as 3D models, images, or animations. Think of apps like Pokemon Go or IKEA's AR furniture placement tool. Virtual reality, VR, on the other hand, creates completely immersive digital experiences, often requiring headsets like the Oculus or HTC Vive. Both technologies are transforming industries from gaming and simulations to virtual shopping and medical training. Testing these immersive applications is key to ensuring usability and performance. AR and VR testing is essential for several reasons. Usability. Applications must allow users to interact seamlessly with the environment, whether through gestures, controllers, or gaze based navigation. Performance. Smooth rendering and minimal latency are critical to avoid glitches and maintain immersion. User comfort. Poorly optimized VR experiences can cause motion sickness or discomfort. Compatibility. Applications must work across a range of devices, from high end VR headsets to AR enabled smartphones. Thorough testing ensures users have a smooth, enjoyable experience without technical interruptions. AR VR testing introduces unique challenges. Hardware dependency. Testing requires access to specific devices like VR headsets, AR glasses, or high resolution cameras, making it hardware intensive. Environmental factors. AR applications rely on real world settings like lighting and surfaces, which vary significantly and affect performance. Performance issues. The rendering demands of AR/VR are extremely high, requiring smooth frame rates to maintain immersion. User comfort. Applications must minimize motion sickness by avoiding latency or sudden, unnatural movements. To overcome AR/VR testing challenges, specialized tools are essential. Unity Test Framework for functional testing of AR/VR apps built in Unity. Blender, a tool to simulate and test 3D environments, animations, and object interactions. TestRail manages and tracks AR/VR specific test cases effectively. VRTK, Virtual Reality Toolkit, an open source framework for testing VR interactions and usability. XR Interaction Toolkit focuses on testing user interactions and usability for Unity based AR VR projects. These tools simplify testing, allowing you to focus on improving the overall experience. AR VR testing involves multiple types of testing. Functional testing ensures that gestures, object interactions, and navigation features work as intended. Performance testing measures rendering times, frame rates, and latency to ensure smooth operation. Usability testing evaluates the overall user experience, focusing on comfort, ease of interaction, and satisfaction. Device compatibility tests applications across various devices, including headsets, controllers, and AR enabled smartphones. Each type of testing ensures that the AR VR experience meets user expectations. Performance metrics are critical for delivering a flawless AR/VR experience. Frame rate. Smooth visuals require at least 60 FPS with higher frame rates preferred for immersive VR. Latency. In VR, latency must remain below 20 milliseconds to prevent motion sickness. Rendering speed. 3D objects and environments must load quickly and without glitches. Battery usage. AR apps running on smartphones should optimize power consumption to avoid rapid battery drain. Monitoring these metrics ensures a smooth, user friendly experience. To succeed in AR/VR testing, follow these best practices. Test in diverse environments, including varying lighting and physical conditions, to simulate real world usage. Simulate real world user interactions, such as gestures, voice commands, and controller based inputs. Use a mix of emulators and physical devices to cover all edge cases. Regularly update test cases to keep pace with new devices and platform updates. These practices ensure your AR/VR application delivers a seamless, immersive experience. Here's a real world example. A retail company developed an AR app to let customers visualize products in their homes. By testing in varied lighting conditions and ensuring compatibility with mid range devices, they delivered a smooth experience. The result was a 20% increase in customer engagement and improved sales. In conclusion, AR/VR testing ensures that your applications deliver the immersive, high quality experiences users expect. By addressing challenges like hardware dependencies, performance optimization, and user comfort, you can overcome obstacles unique to AR/VR. Leverage specialized tools and follow best practices to ensure your AR/VR applications are ready to meet the demands of diverse users. Thank you for watching. Don't forget to like, subscribe, and stay tuned for more insights in software testing. Thank you for joining us at WinRace Academy. We hope this video is useful to you. Don't forget to like, subscribe, and hit the bell icon for more expert content. See you in the next video.